Now in this video we'll start discussing about the very first turbine, that is the Pelton wheel. Now Pelton wheel is a tangential flow turbine because you can see that the jet of water is striking the wheel tangentially. It is also an impulse turbine because at the inlet the only pressure, the only energy you have is the kinetic energy. Okay, so when the water comes down through the penstock, enters a nozzle and flows out, strikes the buckets. So these are your buckets of vanes. So when it strikes it, the entire wheel or the runner starts to rotate, and along this shaft you have some alternator attached. Okay, and then you have a spear. This spear you can turn like this, and you can control the flow rate through the nozzle. Okay, now this is another inlet of water. So this is called the braking jet. So you can use it to stop the Pelton wheel from rotating, because this jet is trying to rotate it in the anti-clockwise direction, and this will strike it in the opposite direction and will try to rotate it in the opposite direction, thus stopping it. Okay, and the enclosure in which this entire assembly is fitted is called the turbine casing. Okay, so this is pretty much the assembly of the Pelton wheel. It's a very simple assembly to understand. Now if you look at this part, which is the vane, or it is also called the bucket in this case, this is designed like this. Okay, so your vane in the Pelton wheel is like this. The water will strike at the center part and will split up into two streams and will come out from the two tips of this bucket. Okay, so let us see what is happening. So this is the bucket from this point to this point. You have the jet coming in horizontally. So you don't have your IVT. Basically IVT is nothing but a straight line in which you have U1, VR1 and VW1, and VF1 becomes 0. So this means for the inlet velocity triangle, I can say that V1 is equal to VW1 and VR1 is equal to V1 minus U1. Now we will also assume that U1 is equal to U2, and let us say this is equal to U. So I can replace this by U. Okay, so we have the VR1, VW1, and because it's a straight line, this means alpha 0 degree and theta also 0 degree. So your IVT reduces to a straight line. So this is how it strikes and then splits up, comes out from the tip at the outlet. This is how it moves out. So you have the OVT, again the similar thing. You have the VR2, you have V2, you have VF2, VW2 and U2. Okay, phi and beta. So if I were to find out, I'm more interested in VWs, because with the help of VWs I can find out the force exerted. Right, so let's find out VW2. This would be VR2 cos phi minus U2, or U simply. Okay, so you have VW2 and you have V1. Okay, so let's use them. So your value of Fx would be equal to rho A into V1, because V1 is the velocity of the jet which is striking the entire bucket. So if you look at this, the value of V1 can be found out with the help of this formula. So let us say the net head available at the inlet is your gross head minus the head loss due to friction in the penstock. So to find out the head loss due to friction, you can use your Darcy-Weisbach equation, d star, where d star is the diameter of the penstock and the diameter of this wheel is capital D. So I use capital D as the dia of the wheel. Okay, so once we have got the HF, we can find out the net head. With net head, I can find out the velocity at inlet, which is V1, which would be nothing but 2g into h. So from here I can find out V1, and I can use it to calculate this part. And then you will have VW1 plus VW2. So this is the force exerted onto this bucket per unit time. Okay, so if you find out the work done per unit time, so you will have rho A V1 into this plus into U. So this is the work done per unit time. So after the work done per second, if you want to find out the power, so power in kilowatts, this would be work done per second by 1000, because this is Newton meter per second. So you will have rho A V1 VW1 plus VW2 into U divided by 1000 kilowatts. So now find out the work done per unit weight or work done per second per unit weight of the water striking per second. Okay, so this will be work per second per unit weight striking per second, weight of water. Okay, so you will have your work done per second, which is this one. So rho A V1 into VW1 plus VW2 into U divided by the weight of the water striking per second. So you will have rho A V1 is the mass of the water striking per second. If you multiply that with G, you get the weight. So you can straight away strike off this, and this would be 1 by G VW1 plus VW2 into U Newton meter per Newton. Okay, so I hope you have understood the mathematics behind these formulas, and you need to remember this velocity diagram for the Pelton wheel. Now after looking at these equations, let's move on to the second analysis of Pelton wheel and look at the efficiency of the Pelton wheel and find out a relation or a condition for the maximum efficiency of the Pelton wheel.